Hello everyone. In basic set theory class, we all have come across this statement that empty set is contained in every set. Well, how does one justify the statement? The answer is given here in this video. First, we shall look at what is a set. A set is a well-defined collection of objects. Now, what is the meaning of this word well-defined? We shall try to understand it with the following two examples. If I consider the set of all names of brave men in the world, there's a problem. What is it? The problem is that the characteristic I'm using here, that is bravery, the definition of bravery according to me may be much different compared to that of yours. Therefore, though I have written a single characteristic in defining this set, the sets that we are going to write may depend on the person who is writing it. That means this is not a well-defined set. Whereas if I consider the set of all names of men in the world who have received the Nobel Prize in the year 2023, okay, this is a good one because irrespective of who is writing this set after the year 2023, all of us will come out with the same set of names. So this is the meaning of the word well defined in the definition of a set. What is a subset? A set A is said to be a subset of a set B if every element of A is in B. And in this case, we write A contained in B using this set inclusion notation. For example, the set of all integers is a subset of the set of all real numbers. If A is not a subset of B, then we denote it using this non-inclusion notation. Should understand that A is not a subset of B if we can find at least one element in A which is not in B. Example, if A is the set of all multiples of 3 and B is the set of all multiples of 6, then A is not a subset of B. I think you can try to find out the reason. Now we shall come to the highlight of this video. Empty set. Why is it a subset of every other set? A set with no elements is termed as empty set, or we often call it as a null set or a void set, and is denoted by the symbol phi. Now how do we show that empty set is contained in every set? If you recall the definition of a subset, it says A will be a subset of B provided every element of A is in B. But the trouble here is empty set doesn't contain any element. Then how do we justify this? The answer is simple. We are going to use the method of contradiction. Suppose empty set is not a subset of A. Then what should happen? Then there should exist an element in the empty set which is not in A. And definitely this cannot be done because we know empty set doesn't contain any element. So this is a contradiction. Therefore, we conclude empty set is contained in every set A. I hope you have understood the reason. Thank you.